Hi, this is an introduction to logic. I'm Mark Thorsby, and this course overviews the basics of categorical, propositional, and predicate logic. Today we're actually going to be discussing the rules of replacement 2. In our last video here, we looked at a whole bunch of rules for replacement, and today we're going to be adding on to them. In fact, here I have a sort of posted version of actually all of the different rules of replacement. You'll see that since I typed this out, I use just a lowercase v to symbolize the disjunction. Every keyboard has a tilde, so that was easy. Microsoft Word does have this little symbol, so I have that in there, the dot we've been using. And instead of using the horseshoe, I'm using I guess it's the greater than symbol here that's on your keyboard. So, and this is typical sort of usage here. So let me make it a little bit bigger here, because what I want to do is just sort of explain them. Last time we looked at De Morgan's, right? Last time we looked at the De Morgan's rule here, in which the De Morgan's basically said that if you have a negation outside of the parentheses, you can get it inside, right? So long as you distribute it to both of the variables and then change the sign, or change, I'm sorry, rather the logical operator from a conjunction to a disjunction, or vice versa, right over here. And commutativity means that if you have disjunctions or conjunctions, you can always just switch them. We looked at associativity, which is basically moving around parentheses when they're combined all with either disjunctions or conjunctions here, right? Notice they're all conjunctions, they're all disjunctions, and you can move around the parentheses. That's what associativity essentially is. Distribution, right? Here's when you have three signs, three variables, three propositions. You have a conjunction or a disjunction on the outside of the parentheses, and then the reverse on the inside, and then you can rephrase it this way. We've also double negation. So that's what we sort of looked at last time. What you'll see is that pretty much all of the rules here, right? All of these rules had to do with either conjunctions or disjunctions, right? And this rule here just had to do with negation. This rule is sort of obvious on its own. But you'll notice what we didn't talk about was any conditionals, right? Because remember, there's the logical operators. You have the negation, you have the conjunction, you have the disjunction. You also have the conditional and the biconditional. And what we're going to see today is in the second set of rules, we're going to see rules of replacement that apply to the conditional and the biconditional. There's one that does apply to the conjunction and the disjunction as well, which is tautology. So don't worry about that for now. The hardest ones, these are actually very powerful rules. These are very powerful rules, and they really help you do a lot. We're going to see it ultimately until we introduce the indirect proof and the conditional proof. We still won't have a full set of tools, but we're very close. Okay, so let's take a look here at how transposition works. And I think the good way to do this is just to sort of inspect the visual argument here and then just sort of take a look at it. So let's actually zoom in here nice and big. Okay, so here's transposition right here. So you can see what transposition says is that if you have a P, right? Whoops. If you have a P, right? And you have a Q, using the conditional, using the if you have a P and you have a Q related with the conditional, right? You can replace that by adding a negation in front of each of these. And so think about that. How does that make sense? Remember the rule of modus tollens? Maybe I can remind you where the rule of modus tollens looks like. Actually, right here. Remember, the rule of modus tollens says that if you have P, then Q, but you don't have Q, then you must not have P, right? Basically, what we're saying is, if this, then this. Well, wait a second. Doesn't that really just mean that if P then Q, that's really the logically equivalent of saying, well, if I don't have Q, I must not have P, right? I must not have P. And that's the rule of, oh, you know what? I think this was here. Oh yeah, there's a mistake right here in transposition. This is a mistake. Sorry. This should be... This should be if Q, then P. I'm sorry. I apologize. This file's been sitting on my computer for a long time. Obviously, I did it wrong, right? I did the explanation correctly, right? So go back here. So the modus tollens says if you have P then Q, but you don't have Q, then you can include P. Well, then basically, doesn't that mean if P then Q, you can replace that? Well, if I don't have Q, I don't have P? And the answer is yes. You can just replace these. These things are logically equivalent. Um, so that's why the rule of transposition, when you write it down correctly, works. So I should have caught that when I was doing this highlighting. Here you go. All right, see that? And see how we just added the negation on the front end? Okay, good. So what does the material implication look like? What is the material implication here? Let's highlight this. Right? If P then Q, that's the same as saying, well, you either don't have P or you have Q, isn't it? Right? Go back here to the modus tollens, right? The modus tollens here, right, says that if P then Q, right? Well, you're either not going to have P, right? If this is the case, then you're either not going to have P or you're going to get Q, right? You're either not going to have P or you're going to get Q, okay? And I hope that makes sense why that's the case. I'm trying to demonstrate it here. Because basically what it means is that, let me use orange here, right? What it means is that if this is true, which we are going to assume if P and Q is true, then that's logically the same as really saying, well, if this is the case, then I either don't have P or I will get Q, which is exactly what this says. So the material implication lets you do that. And what's critical here is the material implication is actually a very, very important rule because it allows us to switch a conditional into a disjunction, okay? Notice transposition still maintains the conditional. So if I'm stuck in the middle of a proof and I need to somehow, I have a premise that's in a conditional, but I know my conclusion is going to end up being with the disjunction and or, then what I can use is the material implication, okay? So let's look here to the next one here. This is material equivalence, right? And material equivalence says, I'm going to make sure I wrote all these down right. If and only if Q, that is logically equivalent to saying if you have P, then you have Q, and if you have Q, then you have P, right? Or, right, if and only if Q, that's logically equivalent to saying if I have P and a Q, or I don't have P and I don't have Q, right? Remember that for the biconditional rule here, this rule, in order for this logical operator to be true, right, both values on either side, the P and the Q, have to both be either true or false, meaning they both have to be what? Logically equivalent. So that's what these essentially look like. And in fact, the biconditional operator here, this was only added after the fact, because originally material equivalence was discovered using just the rules of addition in the conditional. But we found it actually being convenient to write, give it its own logical operator and call it the biconditional. Okay? And so hopefully that makes sense. So what's the next rule here is exportation. What does exportation do? Exportation is an interesting rule. Notice exportation has two different operators going on. It has, on one side of it, it has a conjunction and a conditional, right? On the other side, all you get are just conditionals. Notice the difference here. So that means exportation will be a nice tool to use when you need to switch from having two conditionals into having one, and you need one of these things or vice versa, okay? So the rule of exportation. Now, what does exportation say? It says if you have P and Q, then you get R, right? That's the same as saying, well, if you have P, then you'll have Q, then you'll get R, right? And this may even seem counterintuitive to some people, but this rule is valid, and this is the rule of exportation. I'm thinking about it like this: you're exporting the conjunction out and putting in a conditional that moved into parentheses. Now, tautology here, we actually in an earlier video we looked at tautology. Tautology is when when two things have the exact same logical function, or logically identical ultimately in terms of their bivalence. So if you have two variables, two propositions meaning the same thing, you can simplify. It's not the same simplifying them. It's called tautology because they're ultimately identical, right? And if you did the truth tables here, well, yeah, the truth table looks like this: if true, false, that's true, and that's false, and then this would be true and false, right? Notice this value is identical. Because they're identical, you can always sort of reduce them, or you can reduce any variable, right, to p, or p and p, or you can always take a single variable and then double it using this rule. And this has, you're going to find you don't use the rule of tautology too often, but there are times in which the rule of tautology is very, very helpful. So what I want to do now is I want to do a couple problems from the book. I don't want to take too much time on it because you'll see that ultimately I've already gone over the steps in videos 7.1, 7.2, and 7.3. The steps are identical for doing these problems in terms of building the proofs. You just need to practice using these new rules. That's really all you need to do here. So let me do a couple problems here just so you can sort of see, you get sort of a handle on how to do these problems. So, but I'm not going to do too many of them because I noticed after about 30 minutes, most people will stop watching. So I'm going to try to keep the video down to 30 minutes here. Okay. Oops, I forgot to do this. Okay. I have the problem worked out in front of me already, so and I meant to write it down. So here's the first problem. Let's say if you have not A, and then you have A, then B, right? How can you get to this conclusion, right? How can you get to this? It's very difficult, right? But let's take a look at our rules here and see if we can remind ourselves what the rules look like. Let me pull up a cleaner copy here. Let me pause it and I'll clean up a clean copy. Okay, so what I've done here is I actually pulled up a cleaner copy that'll let us take a look at this problem here. Except now I can't see my screen. My apologies. Okay, so now let's take a look at this problem. So here are the rules here. You can see what the rules are. Here's all the rules we looked at last time. And here's the rules. So let's imagine we have, here, let's just erase this again. Right, so let's imagine we have this not A, and we have to get to A or B. What can we use over here, right? Well, notice we need to have this, right? Well, the rule of replacement, right, is a conditional. Well, let's look over here. And you can see that transposition and material implication both use conditional. So wait a second. If I could get something on this side, well, you can see I can't get a conditional from here. But what about this? You can see the rule of implication allows me to use it if it has a disjunction in it, right? So wait a second. Can't I just add something here, right? Well, let's add not B. So that's going to be not A or B. And that's line 2 addition. Right? And now that I've done the addition, can't I just do the implication? Right? And then just put it backwards. And that's exactly what happens. So that means number 3 becomes A, then B, using line 2 implication. Right? So what I did is I took A, I added something to it, and then I just basically swapped it out and replaced it with a conditional of if P then Q conditional using the rule of implication. Okay, that was an easy problem. Let's do a problem that maybe actually is going to take a little bit more time and is a little bit harder. Okay, if F then G is the first line, the second premise here is going to be F or G, and my conclusion I'm looking for here is G. Okay, man, what can I do with this? Um, you can see that in order to get G, right, I have to get F by itself. So the question is, how can I get F by itself? And I'll tell you, this problem is difficult. You're not going to see immediately how to do it, but I'm going to sort of walk you through the steps to do and then talk about how we can know how to do this. The first step here is actually to do a double negation on line 3 here. Do a double negation here with line F. So you're going to get not F or G, and that's line 2 double negation. Now, why did I do that? Because you're going to see line 4 here is I'm actually going to use the rule of implication again, I believe. Um, right? Because now I have this set up, right? Where notice that, but in this case, right, this is what I have here that fits the rule of implication, right? And so in terms of the rule of implication then, that means I can swap it out with this. But the thing is I have to carry down the other negation that I'm not actually changing. So then I get if not F, then G, right? Where this sequence here got replaced with this sequence here using the rule of implication, right? So that's going to be line 3, implication. And then I'll just do this problem for you because I don't think that it's very difficult to see how to do this without having done lots of proofs over and over. What we're going to do is we're going to do another double negation. It's going to be not G, right? We're going to do a double negation here on the G, so that's line 4 double negation, right? Now that we have that, let's go back over here to our other rules, right? Notice transposition. Transposition here says that, and we can sort of write it up here, is that if you have a if P then Q, that's logically the same, or that's logically equivalent to saying, well, if I don't have Q, then I don't have P, right? So that's transposition here. But take a look at this. Don't I really have a transposition set up right here? Because I do, in fact, have a not G here, and I have a not F here, right? And I have a conditional. Can't I do a transposition here? And the answer is yes, you can. But what does it end up being? Because in the transposition rule, you lose the negations. You flip them around the conditional. So that means line 6 here is going to be not G, then F. Because what I did is I cut out those conditionals. I'm sorry, those negations. And since the rule of transposition here only cuts out one of the negations, this other one just got stuck to the G before I flipped it over here and moved the F over there. And that's how I did that. Now, this probably is very difficult to read, but that's essentially what happens with the negations. And that's where people are going to have trouble with. If you have a negation and the rules over here only have one negation and you have doubles, you just have to carry over the negations across, okay? So this is line 5, transposition. Okay, so what are we going to do next? Let's go over set 7 here, right? Wait a second. What can we do here? Notice now I have not G then F, and look at line 1 here, F then G. Can't I use a hypothetical syllogism here? Because essentially I have an F, whoops. Because essentially I have an F here and I have an F here. I can connect those two together, which means what? Which means that I'll get not G, then G, right? And that's lines 1 and 6, hypothetical syllogism. Okay. Now that I've done a hypothetical syllogism, remember I have this conditional and this. Is there anything I can do here? Well, let's see, what rule implies, well, this rule right here, right? This rule right here seems to, well, the transposition, you could do a transposition, but the question is, why would you do a transposition? Maybe, because remember, my goal is to get G. Now I have G. If not G, then G. So what can I do here with hypothetical syllogism? Well, can't I do an implication here, right? Let's do an implication, which means that I'm going to have to switch the sign and add a negation. So line 8 here is going to be not G or G, right? Um, and that's line 7 implication. Now I have double negation here, so let's get rid of that. So line 9 here becomes double negation, so I have G or G. That's line 8, double negation. And since I have G or G, now isn't that the same right here as the tautology? It is. So line 10 here is just G, line 9, tautology. Okay? And that's the proof for this sequence. Now, this problem is much harder than most of the problems you'll see in your homework. And the reason is because this problem demonstrates how to use all of the different rules simultaneously, but it would be very difficult for you to know how to do this on your own. I imagine if I just handed you this problem, most of you would get really angry after a while. Or it would probably be fairly challenging because you haven't gotten used to even using these rules. So let's do another problem here. One that maybe seemed to be a little bit, they'll demonstrate something a little different here. Pens. Okay. The first problem, the first sequence here is number 1. It says if J then K then L, right? And the conclusion you're looking for here is if K then J then L, right? You can see here what's different. Notice that the K, right, which is in the first position in the conclusion, is in the second position here, right? That's a problem. And the J, right? So the J and the K need to get switched somehow. That's really what this problem is about. How can we actually go ahead and switch those? Let me erase those so you can see it, okay? How do we actually switch those? What can we do here? Well, let's go take a look at our rules here. We haven't used this rule yet. Let's think, well, I'm sorry, we haven't used this rule yet, the exportation rule, and that sort of has a similar sequence where you have a P, then Q, then R. Well, line 1, I think the only thing I can do is an exposition. Well, I mean, I probably could use implication here and stuff like that, but I'm just going to get lost. Ultimately, the goal here is to do what you think you can see and try to do something so long as you see a purpose for doing it. So that means that in this sequence here, I end up with this, right? If J and K, then L, right? And that's line 1, exportation. I'll just put exp, right? And what do I need to do? I need to do another exportation, but now using the rule of commutation, which says that I can move things around if there's a disjunction there. Let's just commutate lines K, line 2. Let's just switch around K and J. So that's line 2, commutation, right? And now that we've done the commutation, let's re-export it, which means I'll end up with if K, then J, then L, okay? And that's line 3, export, okay? So that's another problem here. Whoops, this should have been line 4, okay. All right, let's do another problem here. Let me see. Let me jump here and do. I don't have the homework pulled up today, unfortunately. But let's do a problem right from the homework here, actually, from the back of the book homework. That is. 2 is H, then not E, and the conclusion we're looking for is G, then not H. So I encourage you to pause the video, see if you can work out this problem. If you can, awesome, start the video back up again and see how we do it. And if you get stuck, obviously turn the video back on. So let's sort of do this here. How can I do this problem? Now notice here, start always by looking at the conclusion here, right? And what I see with the conclusion is I need a J, then not H. Do I have anything like that in my tool set? Obviously, since we have a conditionals, I means I'm not going to worry about material equivalent. Well, maybe. Probably not though. Probably one of these two rules here. I do have something like this here with line. This sort of looks like this, so maybe if I can get an if P then Q. Well, you know, I don't see exactly what to do, and you may not either, so let's just go ahead and do something, right? And here's the first thing I do. Let's do a, well, hold on, let's stop. How could we get this? Is there a way that we could make a let's see, we have a G and H, and we have an E and a not E. is there a way we can get this negation together and create a hypothetical syllogism? That would be my first approach. So, but in order to do that, I have to switch the sides of one of these. E's line 1. Let's do a transposition, actually. Let's do a transposition, which means that I'm going to get not E, then not G, right? And that was line 1, transposition, right? And now that I've really done, now take a look at this. Now I can actually conclude line 4, right? Since I have a not E here and a not E here, that means I can use this as a shortcut, if you will. And that means H, then not G, right? That's line 3, hypothetical syllogism. I'm sorry, line 2 and 3, hypothetical syllogism. Okay, so now we've got this. This still doesn't look quite right, though, does it? There must be a way to somehow fix this up. So what can we do here? We'll go back to the rules here. What do the rules allow us to possibly do? Again, I think we're probably going to be either using transposition or implication. So the question is, which one is better to use at this point? I have a feeling, because if I can reverse these, that may be the way to go. You could see here, I could do a double negation here. I could do a double negation on H, because what does the transposition say? If I want to switch them around, they both have to have negations in front of them. So let's do a double negation on H right here, right? Not G, and that's going to be line 4, double negation. Now that I have the double negation, right? I have a negation here and I have a negation here. I can now use the rule of transposition, right? To swap them around. Of course, what's going to happen with this extra negation is going to get stuck to this H, right? So that means line 6 here is going to become, if I have G, then I have, this gets stuck over here when these get crossed out, right? If G, then not H, okay? And you can see that was the conclusion. And so that was line 5, transposition again, right? So that was transposition. So that wasn't too difficult of a problem. Even though we couldn't immediately see what to do, if you see something, just start doing it, because you can't do anything invalid, and you'll ultimately, right, I think eventually achieve it, eventually get to it. I'll do one last problem here, and then we'll conclude the video. For the rules of replacement. Again, it's pretty much the same stuff, we just have a bigger toolkit, and now we're using everything in our toolkit, minus the indirect and conditional proofs. So let's do this problem here, and I'm just pulling this from the back of the book. Some of these are going to be fairly long. Let's go here. Line 1 is T, and the conclusion is if S, then T. So what the heck can we do with this problem? This looks crazy. Obviously, immediately I have to add something, right? Because I'm going to have to add an S. The question is, where do I add an S, right? So line 2 is going to be T, and the question is, what do I add? Well, in order to know what to add, I better take a look at my rules here, because I need to get a conditional, and you can see right here, boom, 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 this ultimately is what I'm going to be looking for here, is I need T or let's say T or not S. Okay, and that's line 1 addition. Now, why did I add a not S? Because what I'm going to do now here is I'm going to use the rule of commutation and switch them. Right? So you get T, and you get not S or T. That's line 2 commutation. Right? And now that I've commutated it, wait a second. Doesn't that just look exactly like a material implication? Which means that I can just drop the negation in the disjunction and replace with a conditional? Yes, I can. So line 4 here is going to be if S, then T, and that's line 3 implication. Okay, so that wasn't too difficult of a problem, even though it looked like it really was a difficult problem. But the real trick was knowing that you should have added a not S. Because if some people may have just thought, oh, I'll add an S, but if you add that, it's not going to work for you. You have to add the negation S. And the reason is because you had to be able to see that if you do a commutation, then you'll do implication. You can see at this point, these logical proofs are starting to look a lot like chess problems. And when I say chess problems, I'm sure my chess players out there will be annoyed. But chess problems in the sense that in order to do some of these proofs, you really have to be able to sort of see a couple moves ahead, right? And the better you are at this, the further in the future you'll be able to see. You have to sort of see ahead of what you have to do. I mean that is sort of tricky and difficult, but they can be fun. So, well, our videos reached 30 minutes. I'm trying to keep these videos down to 30 minutes from now on because I think a lot of people stop watching them after that anyway. So I'm going to conclude there. So that's our video here on the rules of implication 2, in which we ultimately took a look at the transposition, the material implication. You know, I didn't do a practice problem with material equivalence, but you basically see how to do these. You just have to practice them. We also did an exportation, and we did show tautology. Okay, so those are the rules of replacement that we're going to use. Now, one of the things that's interesting is whenever you have something that's logically equivalent, it could actually be a rule of replacement potentially too. But what we're doing here is we're building the necessary tool set of things you need to know how to do in order to do pretty much proofs for anything. And these are really the rules of replacement that you need to memorize and learn to know, okay? Well, that concludes our video for this time. In our next video, what we're going to take a look at is what we call the conditional proof. And the conditional proof ultimately concerns how to, if you really get stuck, what do you do? And we're going to see the conditional proof is one of our sort of secret weapons that's going to let us do proofs for conditionals when we see no other way to do it. Okay, that's our video for next time. Thanks for watching. I'll see you guys online. Bye.